Question 3 is about magnesium existing as 3 isotopes with a mass of 24, 25 and 26. In terms of their subatomic particles, we have to state the difference between these 3 isotopes of magnesium. Remembering that an isotope has different numbers of neutrons. More specifically, I can work these out then. So the 24 massed magnesium has 12, 25 will have 13, and 26 will have 14. We then have to state how, if at all, the chemical properties of these 3 isotopes differ and give reasons for our answers. Well, we know that chemical properties are determined by electrons. And actually, these 3 isotopes have the same number of electrons. So actually, there'll be no difference. Because chemical properties is determined by electrons, these all have the same electron configuration. The next question then. So, magnesium atoms with a mass of 25 make up 10% of atoms in a sample of magnesium. Magnesium has a relative atomic mass of 24.3. We have to use this information to deduce the percentages of the other 2 magnesium isotopes present in the sample. So, the first thing we're going to have to do is make some assumptions. If we know that we've got 24 magnesium, we've got 25 magnesium, we've got 26 magnesium. We know that 10% of 25 magnesium is 10. Sorry, we know 10% of magnesium 25 is 10. Yeah, we've just said that. If we assume that 24 is X, then 26 must be, if there is 100 and 10 of them have already gone, must be 90 minus X. Okay. Now to make it a little bit easier, because normally when I do this calculation I divide by 100, I'm just going to start by dividing these numbers by 100. So I'm going to make that 0.1 and I'm going to make 0.01. No, 0.1, never mind me. And I'm going to make that 0.9 minus X, just to make life a little easier for myself in the next bit. So, we know that the relative atomic mass is 24.3. We would work that out by doing the mass of 1 magnesium, so I've got 24, multiplied by the percentage abundance, which is X. I would then add that to the mass of the next magnesium, which is 25, times the relative abundance, which I've changed to 0.1. I would then add that to the next mass of magnesium, which is 26, plus 0.9 minus X. Okay, so that's my equation that I'm going to need to use. Now, I'm going to get rid of my brackets then. So 24.3 is equal to 24x plus 2.5 plus 23.4 minus 26x. So all I've done there is 24 times x to get that, 25 times 0.1 to get that, and then here I've got 26 plus 0.9, and I've got 26 times x. Okay, so from there then I can simplify this further. I can add these 2 together, so I'm going to have 24.3 equals 24x plus 25.9 minus 26x. I can then get rid of my 25.9, so I'm going to subtract that on the left, and it will give me minus 1.6 26x is equal to 24x minus 26x. 24x minus 26x will give me minus 2x, so minus 1.6 is equal to minus 2x, meaning that the value of 1x must be 0.8. Okay, so if I go back over here then, magnesium with a mass of 24x is equal to 0.8. Here, magnesium 26 was equal to 90 minus x, then we simplified it further to be 0.9 minus x. X had a value of 0.8, so this will be 0.1. Now to turn those back into percentages, I'm going to have 80% of this, 10% of this, and 10% of this. So my final answer is my percentage of 24 magnesium is 80%, and my percentage of 26 magnesium is 10%. Okay, so moving on from there then, we've got another time of flight calculation. These seem to come up on every paper. So, in a time of flight mass spectrometer, ions are accelerated to the same kinetic energy. We've been given the equation for kinetic energy. We've been given the equation for velocity. We're told that in the time of flight mass spectrometer, each 25 magnesium ion is accelerated to an energy of 4.52 times 10 to the minus 16. I'm just going to label that as energy. The time of flight is 1.44 times 10 to the minus 5, and we have to calculate the distance travelled in metres. So, if we want to work out the distance travelled, we're going to need to rearrange this equation first of all. So distance travelled is equal to the velocity times the time. We've been given the time, but we have not got the velocity. So we're going to need to use our kinetic energy equation, and we're going to have to rearrange that for velocity. So velocity equals the square root of the kinetic energy divided by 0.5 times the mass. Now, for the mass, we know that the molecular mass is 25, but we want the mass in kilograms. So we're going to have to take 25, we're going to divide it by 1,000, and then we're going to divide it by Avogadro's number, which we've been given in the question as 6.022 times 10 to the 23. So the actual mass in kilograms of the magnesium is 4.151 times 10 to the minus 26. Now again, I've rounded that to write my answer, but I have kept it up on my calculator. That number is then going to be placed in the equation to work out the velocity. So the question tells me the kinetic energy is 4.52 times 10 to the minus 16. I'm going to divide that by 0.5 multiplied by the mass I just calculated. So keeping that on my calculator gives me a velocity of 147,565. So 147,565. I then want the distance. So using my equation, I know that I'm going to need to do the velocity, which I've just calculated. Again, I'm going to keep that on my calculator. And I'm going to multiply that by the time, which we're told in the question was 1.44 times 10 to the minus 5. So our final answer should be 2.13 metres.